We're going to discuss making recommendations without data.
You want me to move it, apparently?
OK, so our agenda. So we're going to firstly talk about what 5 tribes is, just give you a little bit of a background to the problem we're trying to solve. Then we're going to go through how making recommendations is kind of like an easy and very solved problem. And then making good recommendations is actually the harder part of our discussion. Now, in terms of data, as data scientists, we often expect data to be available. Like you walk into a company, they've got to have data for you. But what happens when we don't have data? How do you make recommendations when you simply don't have data? Then we're going to discuss the deployment and improving kind of process that we were using. And then we'll go into a Q&A session.
Let's start with some background. What was the problem we're trying to solve? The way we meet people is random. We meet people at school or university. We meet people where we work. We meet people near the place we live. That it shouldn't necessarily be that way, though, because we're very well connected, yet it's so hard to meet people with similar interests. Let me ask you a question. Who here owns a dog? No one? So if you wanted to... Who here doesn't own a dog? See? If you wanted to meet people that didn't own a dog, what would be your best chance? You would have to go to each one of them and ask them, do you own a dog or do you not own a dog? It wouldn't work. So our mission in 6 Tribes was to actually make it easier for people to meet like-minded people, and to remove the randomness from this process and make it a little bit easier. The way we did that was by building a social network that connected you, that was recommending and grouping you around the people that share the same interests as you. And we did that, and we call these groups tribes. So this is an instance of a tribe, and this is a tribe around people that like to craft things.
OK, so now let's think about how recommendations are actually easy to make. So firstly, we've got the concept of collaborative filtering. This has now been around for like the last 10 years. So for example, if we take Amazon, let's say you've recently purchased a book, you'll then be recommended other books based on purchases by people that are also purchasing the same kind of things that you purchase. So, OK, so as we have here, a user that joins a particular group, or tribe as we call them, may also want to join tribe Y based on similar users. However, the issue that we kind of have within 6 Tribes itself is that we don't have any historical user data. So therefore, how do we onboard users, like brand new users entirely? OK, so now let's look at something content-based filtering. So this is more about projecting users to an interest space. So here we'll project the user to an interest space and hence derive its tribe. However, the issue with any kind of startup that you actually have is, once again, there's no interest space. So therefore, we literally have a problem with no data.
So how do we find this interest space? In order to define it, we need data. But we had 2 problems with data. We didn't have any historical data, so we couldn't do collaborative filtering. And we didn't have any users, so we were 10 people working in 6 Tribes, and along with our early users, we had 100 people's data to actually define the interest space. But what data did we have? We had our users' Facebook data, and these were posts and likes. And we also had our users' phone data, which could be location and music. So using this data, we had to create an interest space that we would project our users in order to then make the problem, like transform the problem into a similarity search problem. So let's start with music. Now, actually, we don't start with music. We start with location. Yes, that is location. So location, you can get it from 3 main sources. You can get it from the places you were tagged in Facebook. You can get it from your phone photos. You can also get it from your GPS. This is how location data looks like when you take it from your iPhone photo. Now, intuitively, you would think, OK, let's find where our users are spending most of their time in. What are their favorite places? So you would go about into the latitude and longitude. You would use probably an external API like Google Maps API, Foursquare API. You would do some reverse geocoding to find what places are nearby those coordinates. Then you would try to find the most frequent places that your users were spending their time on, and this would be the most his favorite places. Can anyone guess what was the most frequent location in our user data?
What
Home,
is it?
exactly. And it wasn't exactly home. It was all the places near your home. The second most common location was your work. And it wasn't exactly work, it was all the places around your work. So all these data points didn't necessarily mean that you did like these areas or places. It just meant that you worked and lived there. So there was a lot of noise. So this is our initial thing. This is what we end up doing. So what we did is we took our entire users. We reverse geocode every location that they were going to. We found the most popular ones, like Hyde Park or Shoreditch. These were quite common among our users, our 100 users. And we hard-coded it, and we were planning to automate that in the future when we would launch the app by doing the same process and eventually having some sort of heuristic or strategy to find the most common locations and places. Now, the second dimension of our users were music. Now, again, we want to find what kind of music our users were into. And what did we have? We had our iPhone music library. So again, the most obvious thing to do to find out what kind of music people like to listen would be to actually go into their music, aggregate, see what's the most common artist that people were using, and see, OK, you're really into that and that artist in order to actually then match you with other people that like the same music. But it wasn't that easy. First of all, because some songs you had in your library weren't actually played. It could just be part of the album that was in your phone. Most importantly, some of these songs were not played recently, so you need to take into account when was this song that was present in the library last played. And it couldn't be recent because of two reasons. Maybe you weren't using the music app on your iPhone, or because your music taste changes over time. And my latest song was from high school, for instance, so you don't want necessarily to take into account 5-6 years time back. Thirdly, the most popular artist in our user base was U2. And this was not because our users really liked U2. It was because Apple decided to push the U2 album to every iPhone user. This is what we ended up doing. Don't take into account the code, is a little bit wrong in the decay, but we ended up decaying, basically taking into account how long ago you were actually listening to that song, not taking into account U2, and taking into account how many times you played that song. The more time you played that song, the more you liked that song. The third dimensions we're using were Facebook likes. Now again, you can say, in order to figure out how you can use likes to actually see what kind of interest your users have, you could say you will have to find out what the like is about. Now, hopefully, Facebook has a category for the likes from the pages you like, but they're not necessarily informative. So for instance, everyone likes restaurants and cafes, but that doesn't necessarily say a lot about you. In some few cases, around 20%, they do provide a category list, which is a little bit more refined. But again, sometimes it's very generic as well. And let's not forget the fact that some of the pages you like are not pages you are actually interested into. It's just your friend created the page, and he forced you to like that page because of some reason. So again, to solve that problem, we actually took this category list, the more refined ones. We selected the ones that were more informative. We created a hard rule before launching again, because we didn't have any users, of 5,000 likes as being a reasonable enough threshold to actually filter out all these friend pages you liked, and took an estimate about the interest that your likes conveyed. Now, another thing we could do in likes, actually, was to use natural language in the description of the like and in the post of the like, which is exactly what we did in posts. So I'm going to describe that process here. Now, with your posts, you have a lot of data. Actually, that was our most informative piece of data. Now, the problem here, again, is that some of the posts you have made in Facebook don't necessarily have a specific meaning. So for instance, here, it doesn't necessarily mean you like Donald Trump. It doesn't necessarily either mean that you don't like him. We don't know. We didn't solve that problem. That is a hard enough problem. So we didn't solve that. We did, though, use the links. When you did post something with a link, we did use those links that were associated with an article. So we want to figure out what sort of articles were you actually, what were the articles that you were sharing in Facebook were talking about. To do that, we used the wrapper, again, I guess, an external API. In our case, it was Prismatic mainly, but you could also use Alchemy API to extract the keywords from the article, the topics, what are the articles are talking about, and then figure out what are the topics that this user is sharing. again, let me say that some of these topics didn't necessarily mean that the user liked the topics because of the previous problem. But a really important takeaway point here with the APIs was the following. It was really informative to use APIs all along, and we did use APIs a lot. But when we did launch, using an API was not a reasonable thing to do for two main reasons. First of all, it was great for explorations, but when we actually launched, the problem was, first of all, APIs are expensive, so you have to pay money for them, and it's okay when you're doing it for 100 people, but when you're doing it for thousands of people, you have to pay the bill. Secondly, it produces an overhead. So our pipeline was basically when someone was signing up, we had 5 seconds to actually make a first sophisticated recommendation about which other users or other user groups you would be interested in. And the network overhead basically was slowing that process down. So that's why we did all these curated lists.
Okay, so let's go on to making recommendations without data is impossible. Or is it? Okay, so as Nick may have mentioned, we had a very few amount of users. So we actually had 10 users for the first 4 months. Then we launched, and then we got our first 100, etc. So our data was very limited. So therefore, producing a recommendation system with 10 users isn't really very scalable. So that's why we had to deal with a lot of enrichment, like we just discussed. Now, in terms of our user document itself, just to be crystal clear as well, this is Mickey Mouse. So this is exactly what Mickey Mouse's document should look like. So we have things such as like the age, the gender, places, which is dealt with Nick's extraction process, using any kind of other APIs that we can find, as well as things like artists. So Mickey's very keen on Walt Disney right now. On top of that, also interests. So things like a steamboat, dog because he owns Pluto, concert, composing, theatre. So we list basically your interests based on your alchemy and based on prismatic kind of APIs that we're using, all from your posts so that they retain relevance. Okay, so now let's move on to the concept of a tribe. Now with a tribe, we deal with things such as like crafty cats, the actual name itself, dealing with things such as age in order to deal with filtering out and thresholding. We deal with genders as well, which is kind of a controversial one that I wasn't keen on, but our CEO kind of made us do it. And then we also dealt with the interests and like location for hyperlocation. So things such as if you want more of a community-based tribe, or whether or not you want maybe like a London-based only kind of tribe, or even like a country-based tribe. That's predominantly for location, as well as the concept of the radius as well. So now if we go on, let's think about how we make a recommendation system. So we're going to use something similarity search. And the way we kind of do it is we look at it in 3 kind of components. We look at the original analysis, then the matching, and then the scoring. And I'll just talk you through each one. So now if we look at that analyzing, so one of our primary focuses was to actually use Elasticsearch. And this is where Elasticsearch really came into its power. So if anyone who's used it, you can change the mappings, you can kind of change the settings, and you can tweak it accordingly so that it actually returns really precise search results. However, we're using it here beyond search results. So maybe we'll add things such as synonyms, things like Kong Foodies clearly is related to food. But our tribe names actually became really kind of quite complex. So you no longer knew whether or not they're about food or whether or not they're about music. So we use that in order to allow kind of like searches based on interests. As well as that, we use kind of the normal kind of things such as stemming and such as like standardizing the text that was both given and indexed. Okay, moving on as well, we get matching. Okay, so matching was kind of like our key part in terms of building the recommendation system. So obviously we've only got 10 users, so we have to kind of like use a naive best approach that we can. So what we did is we did like a search by a weighted vector using a boosting ability according to your interests. Now some of you who may be familiar with Elasticsearch may wonder why we didn't use more like this. Well, the issue with more like this is if you give it an empty body, it will return to you lots of random documents according to when they're inserted by. It won't actually give you relevant documents according to interests. So this actually leads us on to a further ability that we had to do, which is the concept of scoring. Now, with regards to scoring, we looked at both age, gender, and location. And what you can actually do within Elasticsearch is as and when you get results back and at search time, you can kind of predetermine what kind of score and what kind of metrics you want to prioritize over others. So therefore, you can say if something's like age range, for example, is really important, and maybe you want kind of like a hipstery, Hoxton-based tribe, and therefore you want to limit the age range from 18 to 25, etc. So this was kind of concept. This is all written in Groovy here. And then, as I mentioned previously as well, gender. You can do genderized tribes. As I said, I don't agree with this at all. This actually got removed entirely as a result of basically returning bad results and as a result of gender equality right now. So this was really unnecessary for us. And also in terms of location, so what happens when a user simply doesn't have any interests? So once again, we need to have a fallback kind of method. So our fallback was really like using location and really trying to have an understanding of hypersensitive location tribes, as well as maybe tribes on like a country or city level, etc. So these are all integration as to how we can make a recommendation system with very little data. Okay, now on the engineering side, I'm just going to briefly talk you through the microservice, the deployment and improving, the error handling, and the scalability. So now if we go into microservice, now as a data scientist, quite often you've probably all experienced, you'll do something in data science, you'll pass on a Python script, maybe pass on some other kind of script, and it will get embedded into your Scala backend or whatever kind of backend you're using. Usually pass it on to engineers. But when you're in a particularly small startup, you simply don't have the privilege, I guess, of doing that. So we decided to do it slightly different for many reasons. We wanted to iterate quickly, and we wanted to be able to make these changes in production immediately so that they'd hit the app straight away. And how we did this was having our app, then having like our Scala backend, and then we actually provided a Flask data science API as a microservice, which dealt with all of our data science requests, things such as like returning the tribes, returning another concept as well called social DNA. And then we would use things such as like S3 for our raw data, as well as like Elasticsearch, as I said, to deal with the transform data and to deal with the actual matching itself. So now this is kind of like what our endpoint would really look like. So it was very much about getting the tribes, matching the user ID, and then returning the particular score that we've calculated by tweaking that Elasticsearch. Now, deployment and improving. So some of you may have heard of Circle CI. Now, this was actually really key for us because we wanted to make sure that as we deploy to production straight away, when we're dealing with such a small kind of like startup at the stage, then we can ensure that it's consistent, ensure that it's good kind of quality code, and that it's not going to break anything with regards to production and with regards to the back end. So we use Circle CI as our continuous improvement. And we also use things such as like AWS, Elastic Beanstalk, and S3 to really host our microservice, as well as deal with both the raw data and the transform data. And then also, actually, just to mention, so the really important thing for us was, in a very small startup, only 10 people data for the first 4 months, was getting this kind of like feedback loop. Now, as most of you know, you can get user feedback. Maybe they dismiss something on an app, etc. But right now, this is pre-release to an app. So how do we kind of get this feedback? So it did very much involve showing people what tribes they were matching to and saying to them what is working, what isn't working. Being able to go to our friends and say, do you mind us trying out your data? Can we show you whether or not it works or not? And we were constantly working on this kind of like feedback, improve, and iteration in order to improve matches. Now, this was really key. So we used to prep up data for user testers to come into our company, test it out on them, and see kind of like what they think, so we could really retain the freshness. Okay, in terms of error handling, so something which I found really useful, particularly having a microservice, is actually using opbeat. So if anyone's ever used opbeat, the great advantage of this over normal logging is you get to see what the variables contain as and when it goes through your code and when you find an error. So for example, like if all of a sudden we were finding a particular data string was causing a massive error, which hopefully it wasn't, but if it was, we could then go back and we could trace back exactly what experience that user's had. So this was a really great tool, and I really recommend people looking at this in the future. And then scalability. As I mentioned, the advantage of Elasticsearch is really its ability to scale. It is primarily a search tool, but it can work very well with these tweaks and these personalized mappings as a recommendation system. But it works well at scaling. So it meant like if we were to get 100 million downloads, which we never quite got, it means that we didn't have an issue with regards to that. Okay, now going on to our lessons learned.
Awesome. We have 20 minutes, so I can go through it very, very slowly.
We could technically go through 10, but and then Q&A.
So sandbox research time basically refers to don't spend too much time on exploring things. You actually have to ship things. Our CEO, business people, you know how they are, wanted some deliverables always, some reason. So sandbox your research time. That makes pass the expectations on how much is it going to take. It's really important sometimes, if you want your sanity. Yeah. Start off with as much data and engagement. So this is the point I was trying to convey. Like, use external APIs, use as many resources as you have, but also touch reality when you want to deploy. They are both expensive, and they are both expensive in money and expensive in time. So use them to actually learn quickly, but then also spend some time to actually deploy and explore an area that can go to production.
Yeah. And then the other point, Sarah, is really think about real-time versus batch. So when we were first dealing with our research kind of component, we were very much dealing with a very long, slow process with regards to like using lots of APIs. And what we found is we could deliver results very quickly to users by cutting out those APIs and then by using APIs in the background. So therefore, when a user would first join the app, maybe their searches and their matches weren't great. But then as they used the app, like 30 seconds in, I'd say, all of a sudden they would dramatically improve. But we made sure that improvement was also continuous and that improvement made sense to them. Also, don't make assumptions. So something which we often did very early on into the app was, particularly with data and having so few data, we made assumptions. So we made an assumption, for example, that everyone prioritized music. It actually turns out not everyone is considering music as one of their main interests. So therefore, why do we treat it as a separate interest? And we actually had to treat it as a separate interest due to business demand, I guess. And it turns out that it made our matches really bad. However, what we did is we found actual user feedback, fed that back into the app, and hence we removed the kind of musical aspect. So I think it's really important, particularly when you're working with a very small amount of data and you're trying to build a startup like this. Okay, now let's go on to our Q&A time. So has anyone got any questions that they'd like to ask whilst we're here?
Oh, God damn it.
Okay, so thanks for the talk. You mentioned a debugging tool earlier. Can I just clarify what that was? Because I didn't catch it.
It's called OpBeat, so O-P Beat. Yeah, I really recommend it. It's quite easy to integrate into your app. So it just takes an OpBeat token, and that's about it. And then I believe there's a Flask library as well to handle.
There's also an application. So basically, you can learn when your code fails before your CEO does. Really important.
Yeah. Okay, any more questions that we have? Yeah.
Have you tried Elasticsearch percolators?
No, I haven't actually. That's an area that I'm not familiar with.
Okay. Yeah, I was just wondering because I think it allows you to put in a query and get back the best matches.
Yes, are you referring to more like this as a query?
No.
Because that's one very similar.
There were some problems with the location, and so because where the information was living, and it would be a nice thing to explore, and we did explore it, but there was some complication with location that it was like the location of the tribe was actually living in Elasticsearch, so you didn't have it in query time to query against. So it was a nice thing we could have done if our CEO wasn't caring about location. But
yeah, was it the concept in regards to changing the radius?
I think that Aris wanted to do.
Yeah, the change. Okay.
Okay, thank you.
No worries. Okay.
Yeah.
Hey, did you do any explanations of these recommendations? Do you ever get users asking for explanations, or did you try out showing it to them? Because it seems like you had a pretty good understanding of your features, so you'd be able to say this is a location recommendation, or here are some people who like the same artists as you.
We did, and what we didn't mention maybe very well in this is that in the user profile, we actually gave back some of these interest-based vectors. So another part of our work was to actually display all these interests we thought you have. So that gave them some part of the explanation, because you could see 20 most relevant tags about your music, where you hang out, like what are you interested in. You could actually see it in your profile and figure out why you were suggested to certain things. Now, when we were lucky enough to have users in-house, then some people actually wondered, as Ruby mentioned, about the gender, because gender, for instance, for parenting was only, for some reason, again, business decision targeted in women, if I remember correctly,
Yeah.
and a parent who was a male, it happens, was asking why he wasn't getting the parenting tribe. And this is when we changed
Yeah, this
that.
is when we had to change our algorithm, really. So we often took feedback. So as Nick just said, a man wanted to join a parenting tribe, and our CEO, who we very, very disagreed with on this, like I had a very long argument, basically said, oh, let's make it a women's only tribe. And I was like, no, we're not going to do that. But that's a long story that I should say off camera.
What about feminism? Feminism. was
Yeah,
a good debate.
feminism's probably a better example. There you go.
Feminism. It was
Apparently
targeted-
feminists can
yeah.
only be female.
Be aware of that.
Okay, we got any more questions in the audience? Okay, so I think the plan now is
Wait.
to head to, oh, we have got another.
I know you
Okay.
all want to download 6 tribes at the moment. Don't, because it doesn't exist.
Yeah, it's become
It
something
went
else.
bust.
We can give you a hint. It's like to do with Jeremy Clarkson, so you can kind of imagine like what it's become.
Feminist tribe, right?
Yeah, of course, it's become a feminist tribe.
So you were saying about the, as you got more data, it became more refined. So how often did people change tribes? And did that often lead to people saying, oh, hang on, they've changed tribes, I don't want to be in this tribe anymore, and churn,
Yeah.
for example?
So in terms of behavioural changes, in terms of like leaving, etc., we were using more about when people were joining a particular tribe to treat that like as a positive kind of response. In terms of like leaving tribes, we weren't able to get to that kind of stage in terms of behavioural aspects feeding back in. We did get to a stage of creating tribes. So if your tribe wasn't found, then you could create it accordingly, as well as searching on keywords, which is kind of quite handy. Startups run out of money sometimes. It's not good.
But yeah, if we hadn't, then yes, the plan was to actually then train models to learn from this behavior, because after some point we did have this sort of data because people started using the app, plus we were building a collaborative filtering, because again, we did have some users having joined some tribes. So then the problem became, okay, some people did come and we don't know anything about them, but then we also have these people that are in the app and we want to actually recommend them new other tribes according to the tribes they joined. They choose to join. So that we actually started developing in a collaborative filtering algorithm using Spark, but we went out of money.
Bad
It
times.
happens.
It's okay. We're both working freelance right now.
I'm not.
So
I'm not.
are you not?
Freelance.
Okay, I am working freelance, so get in touch with me. Okay, so anyway, that will wrap up the talk. So thank you very much for listening.